Here's a few examples from page 16 of your notes that I've done out for you. So, first one, part A, you're given this matrix as to find the determinant. Now, straight away I see that I have ones all across the first row and down the first column. So what I'll do, first of all, is I'll do that trick of adding multiples of one row or subtracting one row from another in order to get zeros down along there. So I'm going to take the first row and I'm going to subtract it from every other row. So row 2 becomes row 2 minus row 1, row 3 becomes row 3 minus row 1, and row 4 becomes row 4 minus row 1. So that gives me the 0 here. 1 plus a minus 1 gives me a, right? And then zeros in the rest of the row, it's 1 minus 1. On the third row, that 1 becomes a 0, 1 minus 1. That 1 plus b, take away the 1 from here, becomes just b. And finally 0, and the same with the last row, we get 0, 0, 0 and c. So then I can expand the determinant down the first column. So I take that 1, right? That goes out in front here, and I delete the rest of the row and column, and that's the appropriate cofactor. Now, and then the rest here are all zeros. So that would be like plus 0 times whatever, plus 0 times something, plus 0, whatever, it doesn't matter. Because they're zeros, they come out to 0. So that's why I got zeros down that first column, is so that when I expand the determinant down along that column, I only have one term. So now I go again, and I take that a, and I expand along that row and column. Or expand down that first column, and I get a times that determinant b00c, and I use the formula for a 2 by 2 matrix to get b times c minus 0 times 0, and my final answer for the determinant then is just a times b times c. On this one I'm going to use a very similar trick. So the first thing I'll do is I'll get zeros down the first column. I do that for the second row. I take away the first row from it, and I get my 0 here. For the third row, I take away the first row from the third row, and I get another 0 here. And of course I have to carry that across each row. So this is 1 minus 0 is 0. Here I have AC minus BC here. Then I have a squared plus c squared minus b squared plus c squared. So those c squareds kind of cancel, and I end up with a squared minus b squared. For the third row, 1 here minus this 1 is equal to 0. AB minus BC is equal to AB minus BC, and a squared plus b squared minus b squared plus c squared ends up with a squared minus c squared. So now I expand this determinant along that first column, which only has one term. It's 1 times this determinant, this 2 by 2. Now I could go straight for the 2 by 2 formula, but since I want everything to be factorized out at the end, I'm not going to go for that yet. First, what I'm going to do is I'm going to factorize each of these terms. So if you look at the first one here, AC minus BC, I have a c here and I have a c here. So if I take out that factor, I get c times a minus b. So if you multiply this out, you get ca minus cb, or AC minus BC. And I do the same below it. I take out that factor of b here, and I get b times a minus c. Now on the right here, I've used a formula for the difference of two squares. So it's a general formula. X squared minus y squared is equal to x plus y times x minus y. Try multiplying that out and you'll see it's true. So if I'm factorizing and I see something squared minus something squared, I use this difference of two squares formula. So I've taken a squared minus b squared, and I've said that's a plus b times a minus b. And the same for a squared minus c squared, a plus c times a minus c. The next property of determinants that I'll use is in your notes as number 4, the multiple of a row by a scalar. And that says that multiplying a determinant in front by some number is the same as multiplying that number across a row or down a column. So in this case, I'm using that rule backwards, and I'm taking out that factor of a minus c. So if you look in your notes, going from this line back to this line would be what's shown in property number 4 on page 14 of the notes. So I can take out that factor across one row and put it outside the determinant. So I get a minus c times that other determinant with the a minus c taken out. And I do exactly the same thing with a minus b on the top row. So that a minus b is out in front, and I've taken out that factor in the top row. So again, if you look at property number 4 in your notes, you say they've multiplied in a lambda from outside. So if you apply that here with the a minus b and the a minus c, that's like going backwards through these steps, where you multiply across that a minus b and then that a minus c. So now I have two factors out in front already, and I have a much simpler looking 2 by 2 matrix. So I now just apply the formula for a 2 by 2 determinant, and I get this thing here. So it's c times a plus c, which gives me ac plus c squared, minus b times a plus b, which gives me ab minus b squared. Then I factorize again. So here I have an ac and an ab, so I say that's equal to a times c minus b. I see my c squared minus b squared, so I use difference of two squares, and I say that's c plus b times c minus b. Then I factorize again. See, I now notice I have a c minus b here and a c minus b here. So I take out that factor, and I say it's c minus b times a plus c plus b, or rearranging that, a plus b plus c. And that's my answer. Another way you could have done the last part of that, starting from here, you could do the trick of subtracting or adding a column or a row to another column or row. So here I've taken the first column and I've added the second column to it, c1 plus c2, and that preserves the determinant. So this first column 1 then becomes a plus b plus c, twice, because here I have c plus a plus b, and here I have b plus a plus c. Then I take away the first row from the second row, so I say row 2 becomes row 2 minus row 1. So that cancels out that a plus b plus c. This one minus this one, they're the same thing, gives me 0. And over here I have a plus c minus a plus b. So that's a plus c minus a minus b, which gives me c minus b. And then we just apply the 2 by 2 determinant formula, and it's a plus b plus c here times c minus b. Then there would be a plus 0 times a plus b, but since it's 0, that's gone. And so that's the same answer we got before, except I've sort of used operations with rows and columns to sort of factorize it in here inside the determinant instead of just multiplying it out and then factorizing later. So that's an alternative way of getting that same answer that we just got. Next one, you're given this determinant to calculate. So I'm going to use pretty much the same trick again. I'm going to take away this row 2 here is going to become row 2 minus row 1 so that I get a 0 here. Row 3 will become row 3 minus row 1. So these are two things that preserve the determinant. So I get my 0 there and I get my 1 there. And then for the other terms, my second row is row 2 minus row 1. So it's y minus x here, and then it's y squared minus x squared here. Same the third row. We're taking the third row here minus the first row here. So it's z minus x here, z squared minus x squared here. So I do exactly the same thing that I did before. I expand the determinant down this first column. So that's 1 times the determinant of these 4, and then zeros. So I didn't even bother writing that 1 in here. So I've taken these 4 here and I've applied the difference of two squares rule. So y squared minus x squared becomes y plus x times y minus x, and the same thing here with z squared minus x squared. And then I've applied that same trick of taking out a factor from a row. So I have a y minus x here and a y minus x here. So I put that outside and I take it away. That's left with 1, and that's left with that y plus x from here. I see I have z minus x here and z minus x here, so I can divide both of these by z minus x and put it out here. So I'm just left with a 1 here, and I'm just left with that z plus x down here. So finally, I calculate this 2 by 2 determinant. It's 1 times z plus x, which is z plus x, minus 1 times x, y plus x, which gives me minus y minus x. So that plus and minus x cancel, and I'm left with z minus y. So my final factorized determinant is y minus x times z minus x times z minus y. Last one. Calculate this determinant. Same trick again. I'm going to subtract. This is going to be row 2 replaced with row 2 minus row 1. Row 3 becomes row 3 minus row 1. So those 1s are going to cancel out there, we'll get zeros. So let's do that second row. It's going to be row 2 minus row 1. So we get 1 minus 1 is 0. B minus A here. C plus A minus B plus C. So that's C plus A minus B minus C. So we're left with A minus B. Third row, row 3 minus row 1. 1 minus 1 is 0. C minus A goes here. A plus B minus B plus C comes out to A minus C. So we expand this determinant down the first column. We get 1, which I haven't written, times all this. So that's a 2 by 2 determinant, which we have a formula for. We say B minus A times A minus C minus C minus A times A minus B here. Now I could multiply all this out, but I know the answer is supposed to be 0. So somehow I want this thing and this thing to be the same. So if I look at it, I see I have B minus A here, and I see I have A minus B here, and I have A minus C here and C minus A over here. So what first thing I'll do is I'll take this minus and I'll kind of multiply it in here to C minus A. So minus C minus A is the same as plus minus C plus A, or A minus C. So that's now plus A minus C. And if I sort of take out a factor of minus 1 here from a minus b, that's the same. A minus b is the same as minus 1 times b minus a. So now I have an a minus c here, same as here, and a b minus a here, same as here. So if I put that minus 1 in front, I get minus all this. So now I have this minus itself, so that's 0. If you had just multiplied all these out, you would have eventually got 0 anyway, but that's just the quickest way of doing it. So there you go, a few examples of calculating determinants using the properties of determinants to make it easier and to factorize.